Hey everybody, we are starting chapter 3 today. We're going to come back. I want you to do your own list, but I want you to start off your lists and just kind of list off what numbers are when they're squared, cubed, to the 4th power, and to the 5th power. So go ahead and make your list here. And you don't have to go all the way up to 12 or anything, but remember 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. I want you to make those lists for every one of these so that those numbers are fresh in your mind, okay? So let's go ahead and start. Section 3.1, we're evaluating nth roots. Remember, n is just the variable for some value of roots, and we're going to use rational exponents. And our objective today is that students, you will be able to evaluate nth roots and find the radius of a spherical object given the volume. So we're going to learn about all this, and at the very end, we're going to be able to know the volume of a sphere like a ball or something like that and know how to find the radius. Okay, so really quick, let's go ahead and wake up your math brain. Remember, 5 squared is 25. So the root of 25 is 5. Okay, so don't remember that. Also, the root of 25, remember when you've got this root, there's this invisible 2 here, which tells you I'm looking for 2 groups of the same number. So when I've got the second root or the square root of 25, that's like saying 5 times 5. So the reason why the root of 25 is 5 is because there's 2 5s in this square root, so that becomes a 5, okay? And similarly, if you've got 2 to the 3rd, we know that equals 2 times 2 is 4 times 2 again is 8. So the third root of 8 equals the third root of 2 times 2 times 2, which remember this root just means can we pull out 3 identical things? So 1, 2, 3 2s, which means I can pull a 2 out of the root, and the third root of 8 is just 2. Okay, also remember that when you have, we're going to talk about this a little bit more, but when you have the root of a, that's also saying it as a to the exponent of 1/2. Or the third root of a is the exponent of a to the 1/3. And the fourth root of a is the same as the exponent of 1/4 on a. Okay, so here's our key concept. We're going to fill out this chart together. If you have the real nth roots, meaning, you know, the n could be 2, 3, 4 roots of some value for a. If n is an even integer, so even integers would be 2, 4, 6, 8, and so on. If the value inside the root is less than 0, aka negative, then there are no real roots for that one, okay? Also, if n is an even integer and the value inside the root, or a equals 0, then there's one real nth root, which looks like this. If I've got the root, the second root or the fourth root of 0, then the only real root that you have is 0 itself, okay? And then lastly, we can also write that as the nth root of 0 is 0. And if a is greater than 0, aka a positive, okay, then it will have 2 real roots. And that looks like this. If the n is a positive 2, 4, 6, or 8, so that means the nth root of some positive value for a, we would say is plus or minus the root of, or the nth root of a. We could also say this as plus or minus a to the 1 over n power. Okay, so just go ahead and get that down for now. And let's do this one now. So if n is an odd integer, so remember odds could be like 1, 3, 5, 7, 9, and the value inside of the root is a negative, meaning less than 0, then there's only one real nth root. And this is because if the n is an odd number, I know that an odd power can be a positive or negative. So that means the nth root of some value for a can be written as a to the 1 over n. We also know if a equals 0, there's one real root, which means if you've got the nth root of 0, it's just 0. And if a is greater than 0, then we say the nth root of a is still just 1 because this is odd. And so we say, okay, it's just the nth root of a, or we can say this is a to the 1 over n. Okay, keep that in front of you. We're going to work with that some right now. Okay, it says find the indicated nth roots of a. So if n is the third, so we're looking for the third root of negative 216. So we're going to look at our chart. So remember, we're looking here at an odd integer because 3 is n, and inside is a negative. So this is less than 0 is negative. Then there's just one real root. So we know the third root of negative 216 is really going to be negative 6. And this is because if you did your lists before of things to the third power, I know 6 to the third is 216. So negative 6 to the third is negative 216. Okay, and then for part B here, if I've got the nth root is 4 of a, which is 81. So again, this is our even root, and inside is a positive. So we're going to look at our chart. So here it is. We've got an even root, even, and we've got a positive here. Then we know that there's going to be 2 real nth roots. So we know this is going to be positive or negative, the fourth root of 81. So if you looked at your list of x to the fourth numbers, I know 3 to the fourth equals 81. So that means I know that this is going to be plus or minus 3, because 3 to the fourth power is 81, so that means the fourth root of 81 is 3. Okay, so then this is another reminder. Rational exponents look like this. This is one of our properties. A to the m over n exponents. Remember, this is like a fraction in your exponent. You can rewrite that and separate them. You can put this 1 over n all to the m, or you can write it as the nth root of a to the m power. We also have it for negative exponential roots, where we have a to the m over n equals 1 over, because remember, when we have a negative exponent, that's making it a fraction. 1 over a to the m over n equals 1 over, and then we can rewrite this here, which becomes 1 over the nth root of a to the m. And just be careful that if this is in the denominator, we can't have it equal to 0. Okay, so if we want to evaluate 16 to the 3 halves, I can rewrite this. We're going to put the 16 here. This 2 goes on the root, and this 3 goes right here. Well, I know that the root of 16, so I could also write it like this. The root of 16 is really just 4, and I know 4 to the third power is really just 64, and we can write it just like that. And then evaluate. So remember, again, we've got this negative root, so I can write this as equal to 1 over 32 to the 3/5 power, okay, which would become 1 over, remember, the denominator is what goes on the root, 5th root of 32 to the third power. Now, just keep in mind, when I'm talking about those 5th roots, I'm going to look at that x to the 5th list. So I know 2 to the 5th is really 32. 3 to the 5th is 243, and so on. Okay, well, here's the thing. I know that 32, or the 5th root of 32 is really 2. So I can rewrite this as the 5th root of 32 and everything to the third power. That's okay. So this right here can become a 2. And then this third power stays out front. I know 2 to the third is really 2 times 2 times 2, which is just 8. Okay, so now here's how to do that in a calculator. Using a calculator, if you've got 9 to the 1/5, here's what you're going to do. You're going to go type in the number 9, and then you're going to use your exponent key. So in my calculator, an exponent key looks like this upper caret. And then I'm going to write to that, and then I'm going to write parentheses 1 divided by 5 end parentheses. And I'm going to hit the equal key. So I'm going to get 9 to the 1 over 5, or 1 divided by 5, and I get 1.55. Okay. You get a longer one, but I'm just rounding it to the nearest 2 decimal places. And then this one here as well, in your calculator, you're going to write 12, and then you're going to write your exponent key, parentheses 3 divided by 8, end parentheses, and then hit your equal key. So you're going to go 12 to the parentheses 3 divided by 8, end parentheses, and we get approximately 2.54, and that's if we round to the nearest 2 decimal places. Okay. And then this one here, if you see this fourth root of 7 to the third, you can rewrite that so that we have a fractional exponent instead. That will be easier for you. So in your calculator, you're going to put 7, do your exponent key, parentheses 3 divided by 4, end parentheses, equal key, and we're going to end up with 4.30, approximately to the 2 decimal places. Okay, and then this last one that I'm going to do right now, and then we'll do the rest in class. To solve this equation, remember that we want to get x by itself. So we're going to pull off what we can to get the x by itself. So first thing I'm going to do that's easiest is I'm going to divide both sides by the coefficient of 4 in front of the x. So I end up with x to the 5th equals 128 divided by 4. I'm putting that on my calculator. I get 32. Well, I know to get x by itself, the opposite of x to the 5th power is I'm going to take the 5th root of both sides. This will cancel that out. So we get x equals, and then the 5th root of 32, meaning something times itself 5 times is 32. That's going to give me a positive 2. Okay, so that's it for right now. We're going to finish the rest of the notes in class. Bye.